In this lesson, you're going to learn how to sort, filter, join, and manipulate the data and bring it out of your tables and display it. So let's not waste any more time. Let's jump right into this really fun topic. So here I have open SSMS again. I've already logged into my database and timesheets is open and I'm in tables right now. So we're going to spend all of today in our query window view, that white sheet, which can be a little bit intimidating at first, but don't worry, we'll make sure we break everything down. So the first thing I'd say to do is say new query, but here's a little tip. If I were to say that right now, click on it right now, it says up here on the left, it says master. Why? Because I selected my database server itself, and so it says I'm going to default to master. Now you could change this up here to say timesheets and all is good. Or you could put your cursor anywhere from here on in on timesheets. So this will work, or this will work, or this will work. So you put it here or anywhere inside and say new query now, and it says timesheets up here. It's just one of those little time savers that I try to do all the time just because it's that 2 seconds extra of going up here and changing this that's frustrating. And also, it's really frustrating. You start typing something and nothing seems to work. And you're not sure why. And you go, oh, yeah, wrong database. So it's just one of those simple little things to do. Okay, so you have the blank canvas right now. What are we going to do? Well, we're going to get information out of our tables. So let's start with just pulling information from this employees table. Now, if I right click and say top 1000 rows, we get our 3 rows we have in our table. And there's a script for that, but I'm going to show you how to build this and do it a little easier than this even. So let's start off with the first line. The first line says, what do you want to get out of this table? Whatever table you're going to pull from. So we start by saying select. These are the columns you're going to select. Now, my personal practice is to always say star and then come down here to the next line because I want the IntelliSense to tell me what my available options are. The only way I'll do that is if I also give it which table I'm pulling from. Right now, I don't know which table I'm pulling from, or it doesn't know. I know, but it can't read my mind. So I have to say from dbo.employees. So now I say select star from dbo employees. I could run that if I want to. And if I do, I get our 3 records. But really select star isn't the best practice. Now it is quick, and if you're doing just quick lookups or you're trying to figure something out, select star is fine, okay? But really what you want to do is only get the information you really want. So first name, see the IntelliSense now? Last name, email address, pay rate, and bill rate. We won't bring in the ID, the create date, or the last updated date. For this query, not really important. So if I run this now, notice those other columns drop off. And you see just the columns I asked for. So that's the first thing to know. Select and the column names. And then from and the table name. Pretty simple so far. So now we can manipulate this table by only showing the columns that you want it to. But let's take it one step further. Let's add another statement down here called order by. Now the order by allows us to sort the resulting data. So for example, I could say order by last name. Now notice right now it's Corey, Smith, and Storm. That seems to be in alphabetical order. But I could say DESC at the end, which stands for descending. If I don't put DESC, it assumes I mean ascending. And if I run this, it's not going to look any different. But if I put DESC for descending, it's going to change these three because they're not in descending order, they're in ascending order. And there you go. Storm, Smith, Corey. Now, it might be a little bit confusing to see ascending or descending for a letter field, something that has characters in it. Because what's ascending versus descending? Well, ascending is A through Z, whereas descending is Z to A. And of course, for numbers, it would be 0 to 9, whereas descending would be 9 to 0. And of course, if it was 19, it'd be 19 to 0. If you had a 35, it'd be 35 to 0, whatever. So that's pretty self-explanatory. I think you get it. But the next thing you're going to ask is, well, what if I want to sort by 2 columns? Well, that's really easy. What we can do, let's take off the descending for last name and leave it as just as it is. So it's ascending. But I want to order by last name and then first name. How do we do that? Well, we do it by saying comma, first name. So now we'll have it so that first the last names are in ascending order, and then if we had 2 duplicate last names, the first names would be in order. Okay, we don't have that right now, but what this allows us to do is have 2 things ordered by. Order everything by this, but wherever there's a same entry for more than one row for last name, it will then order it by first name. And you can actually do this as many times as you want. If you want leave it as, well, let's leave it at descending. We'll run that just to show that it works. It does. Now the next thing I want to show you is the where clause. Now the where clause goes before the order by. In fact, order by is the last thing in our list. So we want to put where before that. Where. Now it's going to yell at me right now because I can't say where order by. I have to actually have a where clause, it's called. Now the where clause allows us to do some type of comparison to see if a row gets shown or not. So let's start off with the pay rate. This is a good one. So pay rate right now, I have 3 people, so it's really easy to see once I zoom in. I have Tim Corey gets $100 an hour, Joe Smith gets $125, and Sue Storm gets $150. So what could I do with my where clause? Well, what if I said where pay rate is greater than $110? Well, what that's going to do is only show us rows where the value for the pay rate column is greater than $110. Therefore, this one will not be shown. And let's run this to show that. There we go. We've lost one of our records. It's not gone, it's just not shown in this result view. So the pay rate is greater than 110. Now if I change it to 100, because Tim Corey gets paid $100, right? If we run this, we still only get 2 records because I said greater than. But what if I said greater than or equal to? Now if I run it, I get all 3 records because Tim Corey has a pay rate of exactly 100. And that's what I was looking for, I was looking for greater than 100. Now I'm looking for greater than or equal to 100. Okay, so that's a where clause where I'm doing a comparison against a number. Numbers are pretty easy. But what if we were to change this up and say last name equals Smith? If we run this, only 1 record is returned, Joe Smith, because only he has a last name of Smith. That's pretty straightforward. Last name equals. But what if I didn't want last name equals Smith? Let's just run just this. Notice by hiding just the select and the from, I can take away the where clause and the filter that gets applied. Therefore, now I have 3 records again. So I can see that I have these 3 records, and I want to say, well, I don't want just the Smiths. I want everybody whose last name starts with S. So I can't say last name equals S. That won't work. If I run that, it says, nope, no results. So how do I do it? Well, I change the equals to a like. Now it still won't work. If I run this, nothing happens because I have to use a wildcard character. Now the wildcard character for as many characters as you'd like is the %sign. In other languages, that's sometimes called the star sign, or the 1/8. In SQL, it's the %sign. And so that says I represent 0 or more characters of unknown type. So it's saying you must start with S, but then you can have any kind of character or none after me. Let's run this. And I get 2 records, Sue Storm and Joe Smith. Now, I could say, let's run this again up here. Notice that I have email addresses here, joey@world.net, sue@stormy.net, and tim@corey.com. So I could say, give me only the email addresses that end in .net. Well, to do that, I would change this and say .net. And I change the column name to email address. And if I do that, now I get these 2 records. In fact, if I wanted to, I could go a little bit crazy and say I want every record where the email address has an O in it somewhere. In which case, it's %O%. Run that, I get all 3 rows. Because Stormy has an O in it, World has an O in it, and Corey has an O in it, as well as the com. And Joey. So, what's best practice here? Well, best practice is if you can do an equals or a greater than or less than or greater than an equal or less than or equal, those are more efficient than like. But if you really have to do like, it's more efficient to have no percent sign leading off. Meaning, when we had our last name like and the S percent sign, that is more efficient than that lookup we just did with the O. Because the O one started with a percent sign, meaning we have to look at anywhere in the string. Whereas this can start the string and say it matches or it doesn't. It doesn't have to look through the whole entire string. That's more efficient. So if you have to do a like clause, and you should try to avoid it if you can, but if you can't, don't worry about it. Just try to do this as your next fallback. Start with a letter or letters before your percent sign if you can. If you can't, it's not the end of the world. Unless you work for a really large company where every ounce of speed matters, you can probably get away with this once in a while. Just don't make it an everyday habit. If you find you have to do an everyday search like this, there are ways to optimize your database differently. And we won't cover that in this course because that's really a pretty specific optimization. But doing this once in a while or for ad hoc lookups where you're just doing it once or you're just doing it once in a while, no problem. Okay? SQL Server is very powerful, it has lots of horsepower, it can get it done. We're going to solve that today. We're going to solve that by using what's called a join. So the first thing that I do whenever I do a join, where I'm trying to connect two tables together, is I name or rename each table. Let's start with customers. I would call customers C. Now I just put a space here and put a letter. Now I could call it cust, I could call it CU, I could call it customer. But because we're renaming it, the reason why we're doing that is to shorten this. Because this name can get out of hand. Okay, it can get really huge. So we're saying for the lifespan of this statement, and that's it, we're going to name dbo.customers C. Okay? And if we run this, nothing changes. And if I want to access the fields, I can say C dot, and there's all of my company or customer columns. Okay? So that makes life a little simpler even for the IntelliSense, because it knows specifically, yes, you want one of the columns from customer. So let's just put C star dot star, run it again. Still works the same exact way because nothing's really changed except we've given this an alias. And that's what renaming it is called. It's called giving an alias. But I don't want just customer information. In fact, let's just put just the company name. So if you run this now, it has just the company names. I want to join to the locations table. And I want to say, give me the locations and match them up by their customer number. So I have to say, let's start with showing you what an inner join is. So we say inner join, and then we say the name of the next table. So dbo.locations. And again, I'm going to rename this and say L. So I'm saying select c.company name from dbo.customers, also known as C, inner join. So connect this with this. So I have to say how. How are we going to connect those two? On c.id equals l.customer ID. Okay? Remember in the locations table, we called the customer ID, well, customer ID. And so in the customers table, it's just called ID because that's the primary key for that table. So these two are equivalent. Therefore, that's what we're going to connect on. So now I can say, and I'll show this to you and explain a little more. So now I can say L dot, remember L is locations. Let's do the city name. If we run this, check this out. Acme Inc. is in Scranton. ABC Incorporated is in Washington. And Acme Inc.'s other location is in Du Bois. How did it know that? Well, in the locations table, we said, and let's just pull up, select star from customers, select star from locations. And I really should put DBO in front of these. Notice that case does not matter. And that's something that's true for searches as well as for specific names. But if I highlight both of these statements and I run them, I can see both results in the same area down here, two different windows. So the first one is the customers. And the customer ID is 1, 3, or 4. And down here are the locations. We have customer ID. So Scranton, PA, and Du Bois, Texas are both customer ID number 3, which links up with Acme Inc. Okay, ID number 3. And Main Street, Washington, D.C. is customer ID number 4, which is ABC Incorporated. So that's how SQL is doing this linking, because I told it that the ID in the customers table equals the customer ID in the locations table. So we have now done a join. But you may have noticed something. Let's go back and look at, we have 3 records, 2 for Acme, 1 Scranton, 1 Du Bois, 1 for ABC Incorporated in Washington. But if I run these 2 queries, I see that I have a company called XYZ Corp. And that's not in this list when I run this one. So where did XYZ Corp go? Well, XYZ Corp doesn't have any locations. And you may say, yeah, but it's still a customer. So I want to see it still. Well, that's not a problem. If we want to see all the records from one table and then how they link up to the other table, we can do a left join or a right join. Okay? So instead of an inner join, it's a left join or it's a right join. Sometimes called a left outer join or a right outer join. Left outer join and left join are the same thing. Right outer join and right join are the same thing. So, how do you know if it's left versus right? Well, that's based upon which table comes first. So this one's first, so this one goes on the left over here. This one is second, therefore it goes on the right over here. How you can tell, since I've stacked these up, is think of this as one big line. All right, so if we were to take out these spaces, it's enter keys, make it really long, this is actually a valid SQL statement. The line entries don't matter one way or another. Now, I find this very hard to read, okay, especially if it got any longer. But now it's a little easier to see left versus right. So a left join says, give me all the rows from a left table. And then if they have a match, and here's how you match, if we have a match, give me the row that equates on the right. And if we don't have a match, what we're going to do is anytime we have a field from the right table, locations table, like L.city, we'll just put null there. So let's run that. Now I have 4 rows. XYZ Corp has no city. Acme has 2 locations. ABC has 1. So I've included every record from the company table and their matches if they have any, or null if they don't. So note that even though I said give me all the records from the customers table, that doesn't mean limit me to 1 record each from the customers table. Because Acme has 2 records, because they have 2 connections, 2 matches right here. Therefore, it shows it twice. All right, so let's tone this back down to where we were. So now we have the select on one line, then a from, then a left join on customers. So left join customers connected to locations. Now you may be thinking, well, are you sure it's that way, or is it on the comparison here? And no, it's not on the comparison. It's actually on the tables themselves, where they are in relationship to each other. Now, if we did a right join here, what we'd say is, give me all of the locations, and then if you have a match on the customer, give me that customer information. If not, give me null. If we were to run this, we get just 3 records. And the reason why we don't get any nulls is because the locations table always has an ID for the customer. It makes no sense to have a location without a connected customer. Therefore, you'll always get all the records from locations, whether you do a right join or an inner join. Whereas if we do a left join, we don't necessarily always have customers who have locations. We may have a customer who has no location. And that's the case with XYZ Corp. All right, so let's just write this out so you make sure you got it. You might want to take some notes here if it's at all confusing to you. And if it's not, that's cool. But an inner join means that it is only the records that match. Okay, and that's the match on this right here. So if we don't have a match on either side, we don't include the record. In this case, if we say inner join, which is what we're talking about now, inner join, if we do an inner join here, then we don't have a match on XYZ Corp and a city. Therefore, we don't include that record. A left join is all the records from the left table and all the matching records from the right. Versus a right join, all the records from the right table and all the matching records from the left table. All right, so those are the three join types. It really is just two, an inner and outer join. It's just that when you talk about outer joins, which are outer left and outer right, we have to have the left and right because sometimes you can't change the order around. When you get a little more complex join, that order has to be what it is. All right, so let's talk about a little bit more complex of a query. Let's wipe this out. And let's look at the work done table. Select star from dbo.workdone. And I get basically a whole bunch of numbers. Okay? The only real value I see here is the description field, which tells, oh no, hours worked too. So hours worked and the description. But the location, the job, the employee, none of these really seem to make sense. So here's what we're going to say. We're going to say that the work done table is the important table, meaning we need to have everything match to this table. Now we know that it will match because we're using IDs. We can't have an ID that doesn't match, or at least we shouldn't. Let me back up here. If I were to go into the employees table and delete Tim, whose ID number is 1, we'd have a problem because our link wouldn't work anymore. We wouldn't know who Tim is. Now we could deal with this by making sure our joins are correct and saying always do left joins in here. And then if we delete Tim, we'll know because everything starts showing up as null. That is one good way of dealing with it. But an even better way of dealing with it is saying you can't delete any records out of your employee table or your job table or your location table or your customer table. And that may sound like, oh man, I can't delete records. Really? No, you can't. Because those IDs should last forever, or at least until the ID is nowhere in the system. Typically, what I see a lot of people do is they'll just archive a record. They'll have a flag in there somewhere that's just a 1 or a 0 and call it something like is active. And if they're active, then they show up in lists and all the rest. But say they're a customer and they're no longer an active customer. They'd change that flag in the is active column to say 0. And then when you have a customer drop-down list, they wouldn't show up anymore because they'd filter out any customer that has an is active set to 0. Therefore, you still only see active customers, and yet you haven't deleted that record. That's another way to go about it. A third way of going about it, and we may look at this later in the course, depending on how things go, but another way of looking at it is to set up cascading deletes. And what cascading delete does is it says, okay, if you're going to delete Tim, you're also going to delete everything that's linked to Tim. Everywhere I have an employee ID, we're going to delete that entire record. We're basically going to make Tim never to have existed. Now think about that for a minute. If I worked for a consulting company and then I left and they said, okay, we're going to delete Tim's record. Well, they wouldn't also want to delete all the work I did because now all of a sudden we either have to refund customers money because they've given us money that it looks like they no longer should have, or we have to bill them for less because even though I worked 40 hours for ABC Corp, since I'm gone, that record's deleted, therefore that bill for the 40 hours is also gone. That's a problem. So to come all the way back around, don't delete records. Don't modify their IDs. Don't delete the record. Leave it there. That's the firm and best advice I can give you. Yes, there are exceptions to that, and I'm sure you'll come across them as you go on in your development career with SQL development. But for the 95% of the cases, just don't delete any record that you connect to. All right, so we're going to do our joins here to find out more information about the work that was done. So let's start by first renaming work done to be, let's call it work, or W. So I'm going to say that the important things out of W are W.hours worked and W.description. Okay, those are the important things out of that whole table. There aren't ID numbers. All right, so again, let's pull those up again. Just so we can see it. Okay, so now I want to see the employee's name, not their ID number. So I'm going to join on this table. And again, remember I said you can either do a left join here if you want to make sure that you're only ever including the rows from the work done and having nulls if they don't match. Or you can say, I know that I always have a valid employee ID. I'm going to say we always have valid employee IDs. So I'm going to say inner join. I'm going to say inner join on dbo.employees, we call it E, on w.employee ID equals e.id. So I'm joining the employee ID to that primary key in the employees table. And now I want to say, let's start with E dot. We have first name and last name. But what if I wanted full name? Like first name space last name in one column. Could I do that? Well, sure you can. Let's do it. First name, so E dot first name, plus, I'm going to put another space. I'm going to put my single quote, space, single quote, plus E dot last name. What that gives me is first name, space, last name. Notice no commas in here because it's all one field right here. Now, the only problem with this, if I run this, let's run it. And this is kind of cool. I see hours worked, description, and Tim Corey, and Sue Storm. But check that out. No column name. Why is there no column name? Because we never gave it one. It doesn't know what to call this since we're joining two different things together. First name and last name. So therefore, we have to say as and then give it a name. Let's call this full name inside single quotes. Now if I run this, it says full name for the column name. And in fact, you can do this for every column you want. So for example, description might be better served as explanation of work. And if I can get my single quotes to work. There we go. Actually, my fingers aren't working. All right. So now it says hours worked, explanation of work, and full name. So that's cool. But now I want to keep going because we have other things to pull in. So I'm running this query against work done again. I see that I have job ID. Well, let's pull some more information about the job. But check this out. I am already to the edge of my considerably long screen. How do I fix that? Well, I could keep going if I wanted to, and it's kind of scroll and scroll and scroll. That's a problem. The other thing I could do is I could actually hit enter and go to the next line and just keep putting more stuff. And that works. But typically, what you see people do in the industry is they will if they have to put a second line for their select statement, they'll put every column in its own line. And then make things even weirder, instead of putting the comma on the same line, they start the line off with a comma. Like so. Now, why would you do something like this? Well, if you do something like this, then what you can do is say, you know what, I don't want the description. And you come here and you put 2 single quotes or single dashes. Guess what that just did? It took that column out, but because the comma was here, it allows us to take it out cleanly. Now, it still would work if the comma was up here for this row, but it wouldn't for this row. But now it still does because the comma's here, not up here. Up here, we're assuming a second column. Down here, we're just assuming that we have at least one column. All right, so that right now still works. 739. So that's just a little tip to make your life a little easier. If you don't like that, if you think it looks goofy, or if you don't want that benefit, no problem. It's just something that is a pretty common thing out there. So now that I have my hours worked, explanation of work, and full name, I want to add job information. So I can say inner join dbo.jobs, J, on, and here's the choice I have. I could join to the employees table or to the work done table. Either is acceptable. But the work done table is the one that actually has the job ID in it. So, w.jobid equals j.id. And now I can say, comma, space, j dot job name. And if we look at this, we now see the job name is create timesheet software for these 2 entries. And this one down here is build building. And that's cool. But now, what if you want to pull in the location? Well, we do inner join dbo.locations L on w.locationid equals L.id. And now we can say L.city, comma, L.state. And if you wanted to, L.zip code. And if you run that, we get that even though it's location both have, or at least should have, the same customer ID. So therefore, let's just do j.customer ID equals c.id. And now we can say C dot company name and have all the information you want to see out of our query. Now, that's a pretty complex query. We have 1, 2, 3, 4, 5 tables all joined together to give us this information. That's, in some ways, if you came into this looking at it, you go, whoa, that's a lot of work and it's really scary. But it's not. We are selecting which columns we want. We're saying from which tables, okay? And then we're saying, how do those tables connect? All right, and those are the connections. And that's really all there is to it, okay? You have to watch your joins to make sure you're joining properly so you're not dropping off records when you don't want to. But right now we are doing inner join, and we're saying give us all the records from work done, which in theory means that if we had deleted record from another entry like employees or jobs or locations, if we couldn't match up, then we'd actually drop off that work. So if that were the case, we'd have a little bit of a problem. And that's why I say don't delete records. If you're concerned that you might, just always do left. Because left always points to work done. Run this. Same 3 records. Okay? I'm going to leave it as inner though. All right. Now, the next thing you say is, man, that column order is atrocious. I agree. So let's move that around. I would start by moving company name to the beginning. Let's move worked done down here, or hours worked. So now we can move things around with their comma and have no problems. So let's start with company name and then job name. So I take that column and I move it up here. So if you're not sure what you have so far, run it again. Company name, job name, name of the employee. Let's not call it full name, let's call it employee name. So employee name should be next. And then let's do the explanation of work. It comes next, and then the hours worked. And then finally, which location it is. And there you go. Now notice I combined first and last name for employee name, which means that if I then saved this information somewhere, I couldn't sort by last name because it's combined into one column. That's why whenever I store name information in a database somewhere, like SQL Server, I always make sure that I store first name in its own column and last name in its own column. Trying to break it apart later is such a mess. You're never going to get it perfectly right. So therefore, just make sure that you have that broken apart if you need it. Now the other thing you could do is if you wanted to, you'd flip these two around, make this last name, make this first name, and then put a comma into the quotes. And then this would be last name, comma, first name for the employee name. And then you could sort by last name if you wanted to. All right, so that's our select statement, and that's pretty cool. But what if you want to make sure that we only ever get one company? All right, so let's look at our company list. We could also say, well, yeah, but I don't want to do that. I want to search the company name. No problem. C.company name equals Acme Inc. And that will work as well. But it will not be as efficient. SQL Server loves numbers. It gets numbers, especially whole numbers. It really understands them. It can order them easily, it can sort them, it can filter them, it can do everything you want to do with numbers easily. So if you have the option of looking up based upon an ID, do so. That's the best way of going about it. Doing a text lookup is not as efficient. All right, so there's a lookup by name if you wanted to, or if you wanted to throw in that % there, it would still work the same way. It would not work the same way because it can't be equals. It'd have to be like. And now it works the same way. There we go. All right. We could also do an order by and say, let's order by city. So L.city. And now it's Du Bois first and Scranton next. All right, so we've done our selecting our columns. We've done our complex joining, which isn't complex at all. We've done our where clause, and we've done our order by. So the only other thing I want to mention is the fact that this where clause can have multiple entries, and they are separated by and or. So if I said where, let's first look at our customers. Okay, so Acme and ABC are 3 and 4. So I could say where company name like Acme or C.ID equals 4. 4 is ABC. If I run this, now I get both entries because I have one for Acme and one for ABC Incorporated. So the and or work just like they would inside of algebra. If you're familiar with algebra and are comfortable with that, if you're not, don't freak out that I said algebra. This is not math. Okay, you can stop your flashbacks now. The basics are, if it's or, either one matches, then the record gets shown. If neither matches, the record does not get shown. The alternative is and. Now check this out. If I run this, nothing shows up because company name like Acme ID is number 3, and the ID equals 4. Well, we don't have that match. Therefore, we don't show anything. But if I change this to say A, lead off with like A, I would get a match. 1, ABC Incorporated, because ABC Incorporated starts with A and its ID is 4. Therefore, it's a match. If you want to, you can get even more complex. For example, you could say, let's wrap this in parentheses. So company name like A% and company ID is 4, or C dot, let's do ID equals 3. So now what happens is when we run this, both the Acme and ABC Incorporated show up because is Acme, does it start with A? Well, yes, it does. Does it also have an ID of 4? No. Therefore, that record would not get shown. But wait. Or, so this is right now false for Acme. Or the ID equals 3. Well, is Acme's ID 3? Yes, it is. Therefore, this is true. Therefore, this succeeds, this fails, but because it's an or, the overall record gets shown. So it's just a little more complex adding and figuring out the ands and the ors. And you can make sure that you can draw on a piece of paper if you want. Just think it through, and what you want to say is this true? Is this true? And then you look at the joiner, which is the and or the or. If it's and, both have to be true. If it's or, one has to be true. So do the work inside the parens first, and then compare it to the work outside the parens. Now you could get even more complex if you wanted to, just so you know. I'm not going to demo it. But you could put parens around this and around this, and then say or c.id equals 1. That also works. Gets a lot more complex because you have to think things through, especially if you said something like this. If you say and, now you're really confusing things. So if you can avoid it, don't do this. But I just want to show you that these parens allow you to do more complex operations for your where clause. And you can put them anywhere you want as long as they make logical sense. The only two combiners are and or. All right, so let's tone this way back down. In fact, let's start over. Well, let's just start with this. Company ID equals 4 or company ID equals 3. Oops, equals 3. So that will give us both Acme and ABC Incorporated, and sure enough it does. But what if I had 5 or 6 or 8 numbers? That would get tough, okay? It'd make your query really long. But you can do this, where c.id in, and put your parens, 3, 4. What I've said is, if the ID is 3, or if the ID is 4, then it's true. All right, so I run this, same thing happens. It finds them both. Just to show you this actually does work, if I were to change 3 to 2, now you only see ABC Incorporated. All right, so that's another possibility. You can go as long as you want in this. So if you had 3, 4, 5, 8, 10, 2. I mean, the order doesn't matter, and neither does the sequentialness of it. Okay, so this would still work. If I run this, still works because 3 and 4 are found. The rest are not, therefore nothing happens. All right, so that's the in clause. And that's pretty much it for simple querying. And when I say simple, I don't mean basic necessarily. I call it basic because it's the kind of the standard queries, the select and from and the joins, the wheres and the order by. Make sure your order by is last, by the way. Don't forget that. But there's a lot of power here. You can rename tables for this query. You can join fields together. You can rename fields. Okay, you can do complex where clauses. You can join on multiple tables. select, from, join, where, then order. That comfort level does not happen by watching me do it. The comfort level happens once you do it over and over again. So definitely take advantage of the practice. Don't just speed through this. If you want to learn it and not just see it and kind of understand it, if you actually want to learn this stuff, you must practice. Trust me, I'm talking from experience here. It's only after I did a lot of work in SQL that I really got comfortable with the ins and outs in more than just a head knowledge kind of thing. All right, so that's it for this lesson. Let's go to the homework.